The functions f and g are defined by f of x is equal to 9 over 2x plus 1 and g of x is equal to x minus 3. State a value of x that cannot be in the domain of f. State, because we are demonstrating this in an audiovisual presentation, it is not just good enough to state, because we have to demonstrate the principles on which students should be able to state. But the statement of the problem requires that we state, meaning that we should be able to just look at it and tell what the answer is. The domain of a function is the set of values on which it operates. The function is operating on x. The domain of f consists of values of x. Here we have it. F is operating on x. Therefore, the domain of f will be the values of x. If a value of x cannot be in the domain of f, it means that there is a value of x that does not give a legitimate value when operated on by f. Or we may say that the value of x gives an indefinite result. If there's a value of x that cannot be in the domain, when f operates on that value of x, then it does not give a legitimate result. That is the value of x that we are concerned with. And that value of x may be determined depending on the constructs, depending on the algebraic representation of the function. Different representations will cause our approach to determining the value of x will be different. The most common case that will give an indefinite result for functions is a denominator that is equal to 0. Surely this is a possibility, because we have a denominator and we have a variable denominator. What do we mean by a variable denominator? It means that the denominator is subject to change, and it can take quite a few different values. And the value of the denominator is going to be dependent on the value of x. Because it is not a fixed value, then we are sure that there might be values of x for which we might have values of f that are not legitimate. As we said before, for the most common case that will give an indefinite result for functions is a denominator that is equal to 0. And because we have a variable denominator, then maybe a possible value of the denominator is 0. And that can be justified in this particular case. And that is the assumption that we are making in arriving at the value of x. And if our assumption is correct, then we will have a possible value of x that will cause an illegitimate value of the function. Now we are solving the simple equation 2x plus 1 is equal to 0. But we have right here in the caption that negative 1 plus 1 is equal to 0. 2x plus 1 is equal to 0. Negative 1 plus 1 is equal to 0. Therefore, 2x should be equal to negative 1. And we are taking a look at an approach that can be done quite easily mentally. As the problem states, state a value of x. That means we should be able to state it without actually showing our working. We should be able to do that mentally. We are demonstrating here our mental approach can result in us getting the answer without writing things down. We are saying that if 2x plus 1 is equal to 0, but we know that a negative 1 plus 1 is equal to 0. Therefore, this should be replaced by a negative 1. So then, 2x must be equal to negative 1. Let us demonstrate that. Negative 1 plus 1 is equal to 0. The 2x most definitely should be equal to -1, and 2x is equal to -1, we may eliminate this 2 that is multiplying x by dividing by 2, and we'll do the same on the right hand side. 2 is eliminated from the left hand side, and on the right hand side we have -1/2. Therefore, x is equal to -1/2. The statement of the problem says state. We should be able to look at the expression and write the answer down. If not, then convert the expression to a linear equation and solve it. And I am sure that we do not need to go to that length. If we needed to go to that extent, then the statement of the problem would not simply say state the value of x. Now, we already know the case in point, and the case in point is when the denominator is equal to 0. We already know that the case in point that will give an illegitimate value is when the denominator is equal to 0. So we are going to equate the denominator to 0, and we will solve that equation. Find the value of x by first eliminating the positive 1 that we have here, or the +1 that we have there. That is, and that positive 1 is accompanying the term that contains x. We will eliminate this positive 1 by doing the opposite of +1, which is -1. So we will -1 right on that left hand side in order to eliminate this +1 that we have here, and we need to do the same to the other side in order to maintain the integrity of the equation. Consequently, we have 2x is equal to -1, and we need to eliminate this 2 that is accompanying x by multiplication. We therefore need to eliminate that 2 by the process of division, and we will do the same thing on the right hand side in order to maintain the integrity of the equation, or in order to balance the equation. An equation is a balance. Whatever is on one side is equal to whatever is on the other side. Therefore, if we want to keep both sides equal, what we do to one side, we will have to do that to the other side. 2 is eliminated from the left hand side, and x is equal to -1/2. Another case that will give an illegitimate value is the square root of a negative value. This is not the only way that a function can prove to be illegitimate. If we have a function that contains, for example, a square root, if the value whose square root is taken is a negative value, then that is another illegitimate value for the domain of f of x. This will give an imaginary result, and we do not study imaginary numbers at this level. So we do not do imaginary number at the CXE CSEC level, and maybe that's a reason for us not getting many problems at the CSEC level, which involves the square root of a negative quantity. The reason for a denominator which is equal to 0 being illegitimate is that typically a 0 divisor gives a result that is indefinitely large. That is your reason for a 0 denominator being illegitimate. It will give a result that is indefinitely large, and that is not going to be acceptable as a legitimate figure. For access to hundreds of free videos, please subscribe to our YouTube channel, Richard James Mathematics Resources. For unlimited access to thousands of exclusive full-length videos, please subscribe to our Vimeo channel, Richard James Mathematics Resources.